Hi there, folks. Stephen White's here from the Bing team with some pretty exciting stuff today for those of you who really love science, and even those of you who don't. I have Michael Chava with me today, also from the Bing speech team, and we're here to talk today about what we've done with speech to really enable faster and more accurate speech across a range of devices. So what are we looking at here?
We've had speech scientists and researchers within Microsoft working on some of the biggest challenges within speech technology for a couple of decades now. And we've recently seen some major improvements in terms of accuracy, speech recognition accuracy, and latency.
Okay, so what is this breakthrough?
So it's called deep neural networks, DNN.
How does DNN differ from what we had in the past?
For speech recognition, one of the key components is the acoustic model, which is a computational representation of the acoustic characteristics of the language in question. Deep neural networks is a new version of acoustic model. So essentially, it's a computational framework of how we process speech within the brain.
So we're trying to actually replicate how the brain listens to and interprets speech. Exactly. We're trying to replicate that in silicon, basically. Let's take a look at some of those things that DNN allows us to do on devices like this.
On the one on the left here is what we had previously deployed. The one on the right uses the DNNs. We're going to find a good pizza in Seattle. So you can see the similar accuracy for this command, but you can actually look here down at the latency, which is counted from when I stop talking to when we see the recognition result wait. You can see we're
over a half a second improvement, basically.
Right, so we're cutting the latency in about half a second. We also have the function to text messaging language.
Oh, cool.
So let's try a couple of examples here.
What's for dinner tonight? Should I get something on the way home?
Okay. So faster and more accurate.
A little bit more accurate, yeah.
Great. Okay, so this is great. So basically, again, we're looking at how we can really increase accuracy, really decrease the amount of time it takes to get this stuff done. But what else have we done with these, with DNN?
We're seeing that the DNN is more robust than GMMs is in noisy conditions. So in this app, we actually implemented an option to add some ambient noise. Happy birthday. I hope you're having a great day.
Oh, that's great. So
you see the difference here in
way faster.
Not just latency, but also accuracy.
Well, this is great, Michael. Thanks so much for showing us this today. What is kind of the one thing or a couple of things you want to leave the audience with respect to what DNNs can provide to these devices and these experiences?
So what DNN provides, brings to the table now is better accuracy and reduced latency. So you get better results back from the speech recognizer, and you get it faster.
And so I guess the point really is we're making search more human. We're literally mimicking how humans think, how they process, and ultimately how they actually do things. And we're trying to bring that into silicon, into devices, into experiences that you can use every single day to get things done. Thanks very much. We'll see you soon.